Welcome to Astronomy Daily, your ultimate guide to the latest in space and astronomy news. I'm Anna, your host, and today we're diving into the groundbreaking visual evidence of a star's double detonation demise, shedding new light on cosmic expansion. Then, we'll explore how revolutionary algae bioplastics could enable self-sustaining habitats on Mars. For all you Skywatchers, I'll share how you can spot both the International Space Station and China's Tiangong station in the pre-dawn sky this week. We'll also discuss a new study suggesting the universe might be headed for a big crunch in billions of years. And finally, we'll talk about the largest piece of Mars ever found on Earth, a massive rock set for auction, and the debate surrounding it. It's going to be an exciting journey, so let's get started. For the first time ever, astronomers have captured stunning visual evidence of a star's dramatic exit, a double detonation that marks its explosive death. This groundbreaking discovery centers around a type of stellar explosion known as a Type 1a supernova, which plays an absolutely crucial role in our understanding of the universe. These specific supernovas are not just spectacular cosmic fireworks, they are vital for accurately measuring the universe's expansion rate, a topic currently at the heart of a major cosmological debate. What's more, Type 1a supernovas are also the primary source of iron found throughout the cosmos, making their explosion mechanisms a puzzle astronomers are keen to solve. The evidence for this twin eruption was found by scientists studying two concentric rings of calcium surrounding SNR 0509-67.5, which is the remnant of a star that met its explosive end centuries ago. While astronomers have long theorized that white dwarfs, the dense husks of dead stars, typically explode after steadily accumulating material from a companion star until they reach a critical mass known as the Chandrasekhar limit, hints have suggested other mechanisms might be at play. Using the European Southern Observatory's Very Large Telescope, researchers found those two distinct calcium rings, which offer clear proof that white dwarfs can indeed detonate well before reaching the Chandrasekhar mass limit. This confirms the existence of the double detonation mechanism in nature. The proposed scenario is fascinating. The white dwarf first blankets itself in stolen helium from its neighbor. This helium then ignites, sending a shockwave inward that causes the dead star's core to ignite in a second, much larger explosion. Studying these dual detonations has profound implications, particularly for how we use Type 1a supernovas as standard candles, cosmic benchmarks that explode with consistent brightness, allowing astronomers to measure vast distances and calculate the universe's expansion rate. This tangible evidence not only helps solve a long-standing mystery, but also offers a truly visual spectacle, revealing the inner workings of such a dramatic cosmic event. Moving on, let's head over to Mars. Imagine building a home on Mars that literally grows itself. It sounds like something out of science fiction, but scientists are making strides towards this very possibility with a revolutionary new bioplastic derived from green algae. This innovation could be a game changer for human missions to other worlds, tackling the immense challenge and cost of transporting building materials from Earth. The concept is elegantly simple. If a habitat is constructed from this bioplastic and it can grow algae within its structure, that algae can then produce even more bioplastic. This creates a self-sustaining closed-loop system that could allow extraterrestrial settlements to not only sustain themselves, but also expand over time. It truly echoes the living ships seen in sci-fi classics like Stargate Atlantis or Star Trek. In lab experiments, researchers successfully recreated the challenging atmospheric conditions of Mars, where the air pressure is significantly lower and the atmosphere is rich in carbon dioxide. Despite these harsh conditions, a common green algae called Dunaliella tertiolecta thrived inside a 3D printed growth chamber made from this new bioplastic, which is a type of polylactic acid. The bioplastic material proved crucial, blocking harmful UV radiation while still allowing enough light to penetrate for photosynthesis. Critically, the chamber also created a pressure gradient that allowed liquid water to stabilize within its walls, a key element for life that is otherwise unstable on the Martian surface. This research indicates that even on seemingly barren worlds, organic growth could be harnessed to construct human habitats. This builds upon previous work by the same team, which showed that sheets of silica aerogels could mimic Earth's greenhouse effect to enable biological growth on other planets. Combining these two lines of research could pave the way for a truly sustainable human presence beyond Earth. The next step for the team is to demonstrate that these bioplastic habitats can be grown in a vacuum, simulating conditions for missions to other deep space locations, like the moon. Beyond the exciting prospects for space exploration, this kind of biomaterial technology is expected to have significant spin-off benefits for sustainability here on Earth, offering innovative solutions for our own planet's future. Okay, let's make a quick trip back to Earth. For skywatchers across most of the US and southern Canada, and indeed for many in North America and Europe, there's a fantastic opportunity this week to witness two of humanity's largest orbiting outposts within minutes of each other. I'm talking about the International Space Station, or ISS, and China's Tiangong Space Station. If you're up during the pre-dawn hours, you might even catch both in the sky at the same time on certain mornings. It's truly remarkable how many satellites now orbit Earth, though most of the over 30,700 objects are space junk, too small to see with the unaided eye. But there are about 500 that are large enough and low enough in orbit to be visible. As the distinguished British scientist Desmond King-Haley once put it, a satellite looks like a star that has taken leave of its senses and decided to move off to another part of the sky. The International Space Station is by far the biggest and brightest of these man-made objects. Imagine something almost the length of a football field, including the end zones, powered by solar arrays longer than a Boeing 777's wingspan. Orbiting at an average altitude of about 416 kilometers and moving at a staggering 28,800 kilometers per hour, the ISS completes roughly 15.5 orbits per day. Because of its massive size and highly reflective solar panels, it can appear up to 2.5 times brighter than Venus, and sometimes even flare to an incredible magnitude, making it much brighter than any star. Then there's Tiangong, China's Heavenly Palace space station. While smaller than the ISS, about 1/5 the size, it's still a prominent object in the night sky. It orbits at a slightly lower altitude of about 393 kilometers and can appear as bright as Venus or Jupiter on its most favorable passes. Currently, between the ISS and Tiangong, there are 14 humans living and working in space. Now, if you're wondering when and where to look, it's easier than you might think. From now through the end of July, North Americans and Europeans will have numerous chances to spot both stations, primarily because nights are shorter, allowing these low Earth orbit satellites to remain illuminated by the sun for longer periods. Since both stations circle Earth roughly every 90 minutes, you might even catch them on several consecutive passes. They have slightly different orbital altitudes and inclinations, which makes seeing them simultaneously a less common event, but it is possible. To find out the exact viewing schedule for your specific location, I highly recommend visiting either Chris Pete's Heavens Above website or NASA's Spot the Station. Both are excellent resources. Heavens Above allows you to input your precise latitude and longitude to generate accurate sighting data for both the ISS and Tiangong, NASA's Spot. The station offers a widget where you simply enter your location, and it provides details like the time of the flyover, how long it will be visible, its maximum height in the sky, and the direction it will appear and disappear from your view. Just remember that predictions can change slightly due to orbital adjustments, so it's a good idea to check frequently for updates. Happy sky gazing. Next up, let's talk about an old yet mysterious friend, dark energy. For generations, humanity has looked up at the stars and pondered the ultimate fate of our universe. Will it expand forever into the cold, empty vastness, or is there a more dramatic end in store? A new study, published by physicists from Cornell University, Shanghai Jiao Tong University, and other institutions, suggests we might finally have a surprising and specific answer. Using data from several astronomical surveys, including the Dark Energy Survey and the Dark Energy Spectroscopic Instrument, researchers have developed a model that predicts our universe will meet its end in a big crunch in approximately 33.3 billion years. Considering the universe is currently 13.8 billion years old, this gives us roughly 20 billion years before the curtain falls. This prediction challenges the long-held assumption that the universe will expand indefinitely. Instead, it suggests that after reaching its maximum expansion in about 7 billion years, the universe will begin to contract until everything eventually collapses back into a single point. The key to this theory lies in understanding dark energy, the mysterious force that makes up about 70% of the universe and drives its expansion. For a long time, it was assumed that dark energy behaved like a cosmological constant, maintaining a steady pressure that pushed space apart indefinitely. However, recent observations hint that dark energy might actually be dynamic. The researchers propose a model involving an ultralight particle called an axion, combined with what's known as a negative cosmological constant. You can think of it like a massive rubber band. Initially, the universe expands as this rubber band stretches, but eventually, the elastic force becomes stronger than the expansion, causing everything to snap back together. According to this new model, the universe will continue expanding, but at a gradually slowing rate until it reaches its maximum size, about 69% larger than today, in roughly 7 billion years. Then, gradual contraction will begin as gravitational forces and the negative cosmological constant take over, leading to a rapid collapse in the final moments. It's important to note that this prediction comes with significant uncertainty. The researchers acknowledge that their model has large margins of error due to limited observational data, and the negative cosmological constant that drives their prediction remains highly speculative. Alternative scenarios, including eternal expansion, are still very much on the table. What makes this research particularly exciting isn't just the prediction itself, but the fact that we may soon be able to test it. Several major astronomical projects launching in the coming years are set to provide much more precise measurements of dark energy's behavior. These future observations could potentially confirm, refine, or even rule out the Big Crunch scenario entirely, once and for all. Even if confirmed, a 20 billion year countdown hardly constitutes an immediate crisis for us. To put it in perspective, complex life on Earth has only existed for about 600 million years. 20 billion years represents a time frame so vast that our sun will have died, and our galaxy will have collided with Andromeda long before any cosmic collapse even begins. Nevertheless, this research represents a remarkable achievement in our understanding of the cosmos, providing us with a concrete timeline for what could be the most dramatic event possible, the end of the universe itself. Shifting gears from the vast cosmic scale to something a little closer to home, or at least closer to Earth, we have a fascinating story about a very special rock. The most massive piece of Mars ever found here on Earth could soon sell for up to $4 million in a Sotheby's auction later this month. This incredible meteorite, officially named NWA 16788, weighs a staggering 24.67 kilograms, or about 54.39 pounds. That makes it approximately 70% larger than the previous record holder, another Martian meteorite found in Mali back in 2021. This massive chunk of Mars was discovered by a meteorite hunter in November 2023 in the sparsely populated Agadez region of Niger, an area more renowned for its dinosaur fossils than its meteorites. The Shanghai Astronomy Museum confirmed the rock's Martian identity after a small sample was sent there, and now this interplanetary treasure has a significant price tag. According to the Sotheby's listing, the meteorite shows minimal terrestrial weathering, which means its physical and chemical makeup haven't been significantly altered since it landed in the Sahara Desert. In other words, NWA 16788 is likely a relatively recent arrival on Earth, having fallen from outer space not too long ago. Its characteristics tell us a lot about its journey. Based on a high percentage of a glass called masculinite, along with some shock-melted areas, scientists believe this rock was likely sent hurtling through space when a severe asteroid crashed into Mars. The Sotheby's listing further explains that the meteorite was formed from the slow cooling of Martian magma and is characterized by a coarse-grained texture primarily composed of pyroxene, masculinite, and olivine. However, the sale of such a rare specimen has sparked a debate among some scientists. Paleontologist Steve Broussat from the University of Edinburgh expressed concern to CNN, stating that it would be a shame if it disappeared into the vault of an oligarch, suggesting it belongs in a museum where it can be studied and enjoyed by the public. On the other hand, planetary scientist Julia Cartwright from the University of Leicester offered a different perspective, telling CNN that the scientific interest will remain, and the new owner may be very interested in learning from it, meaning we could still gather a lot of science from this unique find. The Sotheby's auction is scheduled to begin on July 16th. That brings us to the end of another fascinating episode of Astronomy Daily. I hope you've enjoyed exploring the latest cosmic revelations with me, from the explosive end of distant stars and the potential for life-sustaining habitats on Mars, to the visible wonders of our orbiting space stations and the grand theories about the universe's ultimate fate. And of course, the journey of that very special Martian rock. It's been a pleasure sharing these stories with you. Before we sign off, I want to extend a huge thank you for tuning in. If you want to catch up on all the latest space and astronomy news, or listen to any of our previous episodes, be sure to visit our website at astronomydaily.io. That's astronomydaily.io. You can also subscribe to Astronomy Daily on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts to ensure you never miss an episode. I'm Anna, your host, and I look forward to joining you again tomorrow for more captivating insights from the universe. Until then, keep looking up.